In the second part of this tutorial, I'm going to concentrate on the strip and contour functions, very important tools for the structural engineer in quickly analyzing and beginning the design process. To begin, I will click on the draw strip function at the top, and I'm going to draw a strip in any direction as I please. And then I'm going to go to the results manager, and in the results manager, under the strips part, the strips have been updated, and now I have a strip called strip 1, and it's enabled. I'm going to close it, and before I can view any results on the strip, I need to solve it first. So I'm going to click on solve, and it's been solved. So I'm going to click OK, and then scroll up and down, and there we go. We have results on the strip itself. Now open the results manager again. You can choose what type of results you want to view on the strip. So for example, I will choose MXX and close. MXX, close. Scroll up and down to refresh, and the values have been updated on the strip. I'm going to open the results manager again. Now you can change the name of the strip. For example, say you have several strips and you want to change its name. So you can change, for example, this one I'm going to call it T1 as in tutorial 1. You can also change the number of points, increasing basically the accuracy of the results that appear on the strip itself. You can also specify the start and the end of the line manually. You can also adjust the theta, meaning the angle at which the moments are calculated for the strip, or use the local theta of the strip. In this slide, the moment and the shear of the slab is explained in the diagrammatic view. The first is an infinitesimal area of the slab, and the second is an inclined infinitesimal area of the slab. In the next slide, I'll be showing you the different types of thetas that are identified based on the inclination of the area in the strip. In the first case, the strip is perpendicular to the area, identifying the MXX and the MYY. Second case, the area is inclined by theta, thus MII and MJJ are identified. Third case, the area is normal, but the strip is inclined, thus identifying MXX and MYY. The fourth case, both the area and the strip are inclined by the same theta, thus identifying MII and MJJ. The fifth case is the area inclined but at a different angle from the strip itself, thus the theta is not equal to the theta local. Finally, you can adjust the scale of the shown results when having several strips. For example, I'm going to lower the scale through here, click close, and as you notice that the graph or the peak of the graph has decreased. Now, the status of the strip can either be solved or to be solved. This is a functionality which helps especially with several strips, enabling the user to identify which strips still need to be solved and which are solved already, as well as toggle the strip into view or out of view through it as well. I will now move on to the contour. First, open the results manager. The default is the main contour. Enable it, close, and then we need to solve it. So I'm going to click on solve, and the solve dialog box appears. I'm going to close it, click OK, scroll up and down, and there we go. We have the contour map. Toggle on the legend so that we have the contours defined. Now, as you notice that the legend bar is on the right. This is obviously so that it doesn't confuse with the legend bar for the column plots appear over there. You can delete the contour by clicking on X. You can also change its name, change the end value, which refers to the amount of colors in the legend as in the column plot. You can define the minimum and the maximum as in the column plot as well. This has repercussions later on which will be defined. You can adjust the local theta, and obviously you can choose the type of variable from the drop-down menu as in the strip. You can add your own contour using either rectangular contour or the quadrilateral contour. I will click on rectangular contour and click and drag anywhere outside or even inside, or obviously inside the object, and there we go. We have a rectangular contour. Click on solve to run the contour. Click OK, refresh up and down, and there we go. We have the rectangular contour into view. Now, if you open the results manager, the contours have been updated, and we have a new contour called contour 1. You can adjust which variable you want displayed for this contour. You can click close. I will show you an example of a quad contour. This is a very useful and powerful tool. Sometimes the plan is not rectangular, meaning it could have an irregular shape or simply you want to analyze an area and thus include certain objects such as columns or beams and so on. Before I start, I'm going to delete contour 1. So results manager, I'm going to delete contour 1, close, scroll up and down to refresh. Then I'm going to choose quadrilateral contour. I'm going to click any 4 points. And there we go, I have created my quad. Now the maximum number of points is 4, as you can see here. I cannot create any more points. Now you can solve it, click on solve. Okay, scroll up and down, and there we go, we have the results shown. Both the rectangular and the quadrilateral contour tools are very powerful tools, and they are very unique to this package. And this concludes the second part of this tutorial.